Okay, so this is a very relaxed workshop, so we will try to have fun together. And I'm going to present a couple of things now. This is not really a TED talk. I mean, if you want to ask questions while I'm presenting, feel free to do it, but we will have time for questions later. Let me start with the presentation. Essentially, I have a short presentation, which is something that I will present also today at 4, but it will be probably more entertaining, and I will add more details, but essentially this is what you need for the workshop. What we're going to do today is build a multi-agent application with CrewAI. I don't know if you have experience with that. Who has experience with CrewAI? Has experience with it. Okay, that's good. Last workshop, there were like 20 people out of 30, and I was like, okay, let's not do that. Anyhow, with agents, who is playing with agents and any flavor of agents? Okay. Who is using LangGraph? If you're using LangGraph, you have to leave the workshop. So essentially, what we're going to see today is what you're going to learn out of this workshop. And there will be an intro to CrewAI. Stay with me. Maybe it's gonna be boring because I'm showing some code, and I understand that sometimes that's a bit boring, but we will try to understand what's behind that code. Once again, ask questions, and there will be essentially 4 assignments plus 1 bonus. I don't think we will manage to do everything in 3 hours, but I created a website for this workshop, so after that you can just go on the website. Who knows about this website? Who checked my GitHub and installed all the solutions? Just be honest, it's okay. All right, I appreciate that. Don't go on GitHub, please. Essentially, there is this website, and you will see that even if we don't manage to finish all the assignments, it's completely fine. Let's try to meet up and reason about the assignments and ask questions. If you don't manage to write the code, whatever it happens, it's totally fine. This slide is mostly for you. There's one piece missing anyhow. I am a data scientist, AI engineer. I don't know anymore. Once again, it's mostly for you. I'm really approachable if you want to ask me questions. If you hate data science, we can talk about music. I have many topics I'm interested in, but really, I'm really approachable. Let's team up on this. What I've done is a bunch of data science stuff, mainly machine learning for price optimization, but also was working at FreeNow in the automotive and so far so on. All right, so what are we going to learn today? The first thing is to understand how to use CrewAI, and we're going to use CrewAI, which is an open source Python package, because it's really helpful whenever you want to learn how to play with agents. It does the job very well. Sorry, I'm going to get this, otherwise people won't see it here. CrewAI does the job very well to teach you how to implement agents. I really like the framework, I also use it in production, but for learning how to orchestrate agent is great. You will see that all the concepts that have been implemented in CrewAI are really close, really high level. And by the end of the workshop, hopefully you know how to design an agentic AI application, no matter which framework you're using, maybe with CrewAI, but also LangGraph could be a good candidate. All right, what is agentic AI? Essentially, whenever you have agents that are taking actions, that are using external tools, that are kind of reasoning about the environment and taking actions in a very dynamic environment, maybe you can use an agent. Every time I talk about agents, what I like to say, and what I would love you to understand is that agents is not something new. We had agents also in the past. I was studying agents during my PhD, during my university, and is not a new concept. I mean, agents, it's been a while they're around. What changed lately and why, apart from the hype, which is, we can talk about that also as well later maybe, but apart from the hype, what happened is that thanks to the LLM, the agents now have a thinking core. They can reason about the environment and they can take actions. And this is what is actually changing the game now. So we take an action, we take an agent, we put it into dynamic environment, and the agent can take actions based on the inputs that it receives from the environment. And we do this thanks to the LLM. So the LLM is the thinking process under the hood. When can we call it an agent? Essentially, when we have a dynamic environment and it will be too complicated to write a deterministic algorithm to solve a solution. Let's say you want to go from A to B in Porto and you want to write an algorithm that does that for you. But then there are a lot of things happening from A to B, construction sites, maybe there is an incident, there might be many things. Your algorithm, since it's deterministic, it's a set of rules, it's fixed, will fail. What you can do in order to take into account these inputs from the environment is perhaps write an agent, and you're not telling the agent, hey, go from A to B and follow this path, take these actions. But you're saying, just go from A to B, I give you a couple of tools, and you will decide what to do if something goes wrong. And this is the mindset you need to have when it comes with implementing agents. A bit of history, just to give an idea of how we started. A lot of years ago, OpenAI released ChatGPT to the consumers, and this, essentially, we can say that changed the world, and a lot of new things started happening. And what we do with LLMs, it's simply sending a query to a trained large language model, and then we get an answer. This trained large language model, of course, has limitations. I don't know if you remember when people were making fun of ChatGPT and they were saying, oh, look at it, it doesn't know who is the president of the United States. That was intended. It didn't look funny to me, but of course it was a bit funny. But the problem is that no one put that information into the training set. That's pretty much it. And we solved this problem with compound systems, or RAG. Who is familiar with RAG? RAG now is such a old concept. No one cares about RAG anymore. But RAG is actually really important because it's a compound system. It means that we have the LLM, and then we have this retrieval augmented generation. And essentially what we do with RAG is, imagine that you're asking the LLM something about your vacation. The LLM doesn't know anything about that. You didn't train the LLM with those data. But the LLM has the capability, maybe it's an external tool, to query a database, essentially. And that database contains information about your vacation. So we get a query, we send it to the LLM understands that it needs to look for more data, it queries the database, and then it gets information about your vacation. That's it. And at some point, we started talking about agents. With agents, we have all the things that we have seen so far, but in addition to it, we get this reasoning loop. The loop that you see here, this is essentially how you can interpret agents. The loop is the thinking process, which is the LLM essentially thinking about the next steps. And we have an LLM under the hood, but we're not sending the first output that we get from the LLM, but instead we're reasoning about that output. And the reasoning process means that maybe the next action is like if you want to count up to 10 before saying something. Maybe the next action is not the right one. Maybe we need a tool. Maybe we need to work once again on the task. And all this thinking process is done by the LLM. Imagine that you have a bunch of prompts that say, hey, I think given your task, this is not the best solution. We want to do it better. We want to give it another try. We want to use a different tool. And all this reasoning process is happening in that loop, and it happens because the LLM. Am I going too slow? I can go faster than this. CrewAI is not the only framework I'm This is a disclaimer in case I go to jail. There are also other frameworks. CrewAI is open source. I don't work for CrewAI. I contributed to it a bit, but I'm not working for them. There are also other alternatives. When it comes with orchestration, CrewAI is great. I think you should go with CrewAI. It's also good because it's a very high-level package, so it does the job when you have to understand how to implement agents. There are also some other alternatives. For instance, I didn't put it here, but LangGraph is one of those. LangGraph is a really cool alternative. All right, now we check a couple of examples about CrewAI. With CrewAI, who knows Python? Do you know this is a Python workshop, right? How many of us? Okay. But you knew that this was a Python. Yeah, even if you don't know Python, we will make it work. No worries. Next year. All right. So, just kidding. They're recording everything. I'm really sorry, but we will cut it. All right. So, CrewAI essentially it's an open source software that has all the things that you don't want to implement when it comes with orchestrating agents and working with agents, because you have the thinking process built under the hood. So you have a bunch of prompts flying around in the package. You have this sort of orchestration. So you just say, I want to orchestrate this set of tasks, these agents, and the package is going to take care of that. And you have concepts like agent, tasks, and crews. The beauty of using, of course, a package is that, a framework is that you don't have to build the stuff from scratch, but also you have to adapt to the framework. You need to see how it works. And in a nutshell, working with CrewAI, because this is very important, it's probably the most important slide. In a nutshell, working with CrewAI is all about creating a set of agents which looks like building a team. Let's say I want to build a team of data science, like a marketing team. Maybe I need a data scientist, I need someone who takes care of the reports, someone who brings me coffee. All these agents that are working together within the same team are going to be the stuff that we have to implement. Of course, we're talking about a team of people, but with agents, with CrewAI is the same. We want to build a set of agents. This will look like a crew, like a team. And each agent is specialized in creating a report, doing data analysis, creating code, and so forth, so on. Now, let's have a look at a couple of examples. Here, you can stop me if you have questions. We start with the agents. So in CrewAI, if you want to create an agent, this is what you do. You will get the slides after the presentation, no worries. So what you do is importing CrewAI, importing the agent from CrewAI, and what you define inside of it, I hope you can see the code is not too small. What you can define inside of the agent is the role, the goal, and the backstory. If you think about it, this is what, how many prompt engineers do we have here in the room? Don't be shy. Come on, this is a real job now. Prompt engineers, no one? I'm one of them. Every time me and my prompt engineers colleague want to write a prompt, what we usually do is, let's say it's a prompt about doing some data analysis stuff. What we usually write at the beginning of the prompt is, you are a data analyst with 2,000 years of experience, your parents were data analysts, your grandparents were data analysts, and you make it sure that the prompt will not fail. But of course, sometimes it fails and it says, hey, what's up? How are you doing? And of course, it's not intended. We didn't want that. And the reason is that the reason why we write that statement at the beginning of the prompt is that because we want to make sure that there is a strong backstory. And this is what we do here. We define the role, and then we define the goal. We're not telling anything about what to do. And then we define the backstory. So we know what this agent looks like. Potentially, we can take this code. Let's say we're able to run this code, but there's something missing. Like, of course, you don't know CrewAI, but there's something missing. If you think about it, there's the goal, the backstory, the role. But what do you think is missing now? Who knows? Let's make it interactive. Okay. Okay. Let's say that that's a good question. Let's say that the LLM is all set. We have an LLM under the hood that is working, but something is missing. Yeah. API. Okay. Something else. Once again, sorry. Okay. Anything else? Constraints? The tools? Okay. I mean, they're kind of all right answers because we didn't see anything about CrewAI. But of course, what I wanted to say is actually the task. We're not telling this agent what to do. We're just telling this agent what the agent is about. But we didn't say, do this. I mean, when we work with agents, we want them to take actions. And here we say, goal, you are a researcher. Backstory, that's your backstory. You're a data analyst, blah, blah, blah. And the role. But what else? I mean, we need to tell this agent, hey, do this, right? When we write a prompt, we put the initial part and we say, okay, you are a data analyst, please do this. And then we give it some data, right? It's just to make it interactive. That was not a real question. But thanks for the answers. All right, and this is the task, right? So this is what we give to the agent that we saw before. And that we have a description. We have the agent that is going to pick the task. And then we have the expected output. The expected output is really powerful. We can do it in many ways. We will see it. It can be also a Pydantic output. Who knows Pydantic? Okay, it's not a big deal. Pydantic is for data validation. So you're making sure that if you want potatoes as output, you're going to get potatoes. I hope Pydantic will never hear this explanation of their package. Anyhow, it's not a big deal. We will see how it works. But this expected output, apart from using Pydantic, let's say we say something like this, a bullet list summary of top 5 most important AI news. If we do something like this, we're making sure that the output will look like this. And me and my prompt engineers colleagues know very well that when you write a prompt and you want to get something out of it, you don't have much control on that because it's not deterministic. So you have the problem that the prompt is going to give you something you are not expecting because it's hallucinating, and maybe that prompt, whatever you have there, that output is the input of another application. So you're going to break the pipeline. But with this kind of solutions, the expected output, it's something you can control. So it can be the input of another application afterwards. And here was expecting you to be very amazed by this expected output, but this is the future, guys. I mean, anyhow. And then we have the crews. This is the last part. With the things that we have seen before until this point, we can essentially create an application. So we have the agents, the tasks, the process, and some other extra stuff. But essentially, whenever you have a set of agents, a set of tasks, and we tell the agents, you get this task, you get that, you get these other tasks. We put everything here, and we say crew agents, we put all the agents, tasks, all the tasks, the process, in this case sequential, it means that the tasks are going to be executed in a sequential way, and then a couple of more outputs only to have a better verbose logging. And that's it. You take this, you take the agent from before and the task, and you can run the application, and you have the first CrewAI application. Now we dive into a couple of things that we will see during the workshop. The first is the process. The nice thing about CrewAI is that you have 2 different ways of orchestrating agents. One is sequential. You take the tasks and you execute them in a sequential way. The second is hierarchical. It means that you have one manager. This is like building a team of real people. You have one manager that is looking at the work of the underlying agents, and it's saying, hey, maybe you're going in the wrong direction. Maybe you need to pick that task. Maybe you need to do that. And you do this with process hierarchical. And we're gonna use that. And then, of course, we have the, yeah, please. So essentially, where did you see the goal? Did I write goal? Yeah, yeah. The task is literally the task, what the task is going to do. The goal is more like, what's your goal in life? I want to be the greatest prompt engineer of all times. It's for making a bold statement about what the agent is going to do, what the agent is going to be, but not what the agent is going to do. Essentially, the best way to explain this is when you write a prompt. When you write a prompt, you write a very strong and bold backstory about what the prompt is about. But you don't say, you say something like, okay, you are a data analyst, you have years of experience, you do this, you're specialized in this and that. But then after that piece, you have to bring some data and real tasks. And then you say, take this data and give me the best analysis ever. But it's more like your goal in life. My goal is to be the best prompt engineer in the world. But then this doesn't tell you anything about what are my tasks, how to get to that point, or what I'm going to work on today. That's a very good question. Then we have our tools. This is probably what we, data scientists, AI engineers, whatever, are going to do for the next years, probably, writing tools. I think this is our future. We're going to work for our agents. We're going to work for our machines. And writing tools is how you essentially give power to the agents to do very specific stuff. When you write a tool, in this case, I'm not really writing it because I'm using this SerperDev tool, which is something we're going to use. It's an amazing tool. With SerperDev tool, we're going to essentially pass, as you can see here, we have the agent, the role, and the tools. And we're going to tell this agent, hey, you can access this tool if you want. And when you do it, every time you think it's necessary, you can take this tool. And in this case, this tool allows the agent to browse the web. You can browse the web, get information from the web, and then do whatever you want to do based on the tasks that I'm assigning you. So it's an extra power you're giving to the agent. Otherwise, the agent is not able to access the web, of course. And in addition to that, we also have custom tools. So we can write a function, a Python function that does something, and then we can give it to our agent. We just have to follow the structure that is suggested by CrewAI. Another important thing that we're going to see this in the workshop is that if you want, you have this so-called flow. So you can create crews, and you can, based on the output of one crew, you can decide if you want to perhaps call that crew again and get a different output, because maybe the output of that crew contains violence. And it's okay, how can I control that? I don't want to get that as an output. And you can do this with the flow. I don't want to dive too much into this, because you will see it in the assignments. And yeah, so for now we say that if you want, you can build guardrails. This is a very powerful concept, something that I use very often, because sometimes you're working on very, like very critical applications. One example is when I release something for my podcast. The problem that I have is that when there is a new RSS input coming to my pipeline that I use for posting on LinkedIn, I want to be sure that my post doesn't contain violence, or maybe the LLM is hallucinating because I'm writing a post on LinkedIn automatically. What I do with Flow is going back to the output of the crew and say, hey, does it contain violence? Does it make sense as a LinkedIn post? Yes. Okay, continue. Then we have also a way of saying, okay, we have tasks. We saw the tasks. Now we know what a task is about. And we have conditional tasks. So we have operations that we're gonna do only when a specific trigger will be fired. One example is, let's say we have one task that we're giving to an agent, and then we have another task which is called conditional task. But this task is only fired when we have this condition met. Is data missing? So the agent will call this task only when the data are missing. So we have multiple tasks assigned to the agent, but then maybe 2 of them are conditional, and we say, okay, if something happens, we call these tasks. Otherwise, we don't. As we said before, we can play with the input and the output. We will see how. So we can pass input to the tasks. These are our input data. We can also wrap a task. It's a Python class, right? We can wrap it into a function and then pass some parameters. You decide. Or we can do something like this, because CrewAI allows you to pass inputs like in this way. We have food allergies, and when we call our crew, we can pass it in this way. It's a small detail. You will get the examples afterwards. So remember, you can play with the tasks, input and output. Also, very important is that you have the task output. Essentially, you can control this. In this case, I'm saying this task, the expected output, as we saw before, is an image URL, and is the URL of the image that we have generated in a previous step. All right. How do we? Okay. This is, I wanted to be sure that you have a clear overview about this, because of course input and outputs are the most important things when you write an application. This is a bunch of ways you have to control the outputs of an application. This code, if you take it as it is working. This is a CrewAI application. So if you want to write your first CrewAI application, you take this. As you see here, we have an agent. We know what is it. We have a task. And then we have a crew. We put everything together in the crew, and we're ready to go. When we call kickoff, we're executing this. After this, if you call this result, result and output of each task, you can access the output as a raw output, as a JSON, as a Pydantic, so you have different ways. This is just for you to give you an overview of what a CrewAI application looks like and how many ways you have to control the output. Last concept is asynchronous kickoff. If you want, and we will do that during the workshop, you can essentially execute multiple crews. So one crew is a set of agents and tasks. You can execute multiple crew asynchronously. So you can say, we execute the first crew, but under the hood, we want to execute another crew in parallel against some other outputs. Let's say that one crew is a set of agents, and the output, the goal of this crew is to onboard all of us for this conference. So you give your email, you give, I don't know, where are you from, all this information, and it will give you, this crew will give you the QR code of the conference. I don't want to do this sequentially. I want to call as many crews as I can in parallel for all of us. And this is a way you can do it. There is a way you can do it through async IO in CrewAI. Essentially what you do is calling kickoff async against the crew, and you will have multiple crews running in parallel. All right. Now we will start with the workshop after this boring presentation. No presentations anymore. Hands-on guidelines, just most important thing, ask me whatever you want. Help your teammates, classmates. Maybe you know Python very well. Maybe we have some Python contributors here. So please help each other. That's really important, because I'm only one person. So if you already nail the solution, if you know how it works, please try to help. Yeah, just get creative. I put some rules in the website that we're gonna see. but you can do pretty much whatever you want. I mean, the assignment are for you to have some structure. So if something goes wrong, I can show you the solution and we can have a common agreement on what the final solution looks like. But if you want to go rogue and do something completely different, the best CrewAI application ever, feel free to do it. Now, this is the website. I hope that it works. So please try to reach this website. Who doesn't have a laptop? Interesting. It's not a big deal. I mean, you can team up if you want. The Wi-Fi password is same name of the PTH 2025, but after PTH you put exclamation mark. So PTH exclamation mark 2025. Okay. Sorry, the website is wrong. There was a test, you didn't pass it. No one said anything. Can you reach the website? All right. Okay, let's have a look at the website. So this is something I made for the workshop, because otherwise it's always a bunch of slides, and I also don't like it. But this makes everything more interactive. Essentially here, potentially you have all the things that you need. First of all, the presentation deck. So if you click on Porto Deck Hub 2025, you should get the presentation. If you don't, I'll make a change on the fly. If you see something is not working, I can fix it. And here, these are the first two things you need to do. First, we need an LLM. So we need access. Who already has access to an LLM? Who has an API key? 2 people? 3? 4? Come on. 5 people? Okay. Okay, this will be interesting. So we need an LLM, of course, because this is an AI agentic workshop. But you have many alternatives. If you want to use OpenAI, that's I mean, you just go on the website and try to get a key. Otherwise, another option could be OpenRouter, this one. I think it's quite cheap, and with OpenRouter, you don't have to use one specific provider, but you can use, it's a router for many providers. So in general, this is an advice for you. If you don't want to go with OpenAI because you're just experimenting and you're like, I don't need the power of a GPT-5, you use OpenRouter when you want to do experiments, and it will route your request to the cheapest model around. So maybe you can use OpenRouter. Anyhow, first step, you have to get a key as soon as possible. And then you go to this separate API key. This is not, it's not a big deal, but try to get this key because it's really important for the workshop. And essentially, if you sign up, they will give you a key for free, so you don't have to pay anything. And with this key, you have a lot of requests. So you have a lot of requests. If this website is not working, because sometimes, I don't know, they get too many requests and it's not working, it's not a big deal. We can skip this tool for now. It's not a problem. Yeah, and let me know once you're done. I mean, I give you, I don't know, 2-3 minutes to get a key. Who doesn't want to get a key? Just who doesn't want to work with an LLM today? Because that's a breaking deal. Okay. Keep me posted about this thing. Okay, in the meantime, I can show you the website, and then you get the key and all these things that you need, all the things that you need for the workshop. So I'll show you around. Here there is a setup guide. I'm showing how to create an environment with UV. If you're not familiar with it, if you don't care about UV, if you use poetry, use whatever you want. This is a disclaimer. This is something I learned after my previous workshops. You can use whatever you want. If you don't know anything about Python environments, work in a Jupyter lab, notebook, or use Colab. Okay, you can use whatever you want. Who prefers to use Colab? Just it's important, because if you have problems with Colab, let me know, and yeah, we can fix them. Otherwise, if you want to work locally on your machine and you want to set up your environment, I'm leaving the instruction for UV. Once again, it's not a big deal, it's just a Python environment, but I've seen people having a lot of issues with it. Okay, don't forget about the keys. The assignments. I have prepared 4+1 assignment. Each assignment has a bunch of information in it. Essentially, I'm explaining what you have to build and what is the required inputs. These are not like constraints for you. It's just a guideline. If you want to change a couple of things into this for the assignments, you can feel free to do it. And then I'm leaving some resources and some code examples. The code examples are essentially sometimes 80% of the solution. You just have to adapt it to the solution. Can you generate code? Of course you can. There's nothing wrong about it. Maybe don't overdo it, especially with CrewAI. I see that LLMs still, this is a new package, so sometimes they fail and you waste a lot of time fixing errors. And CrewAI is not too much code, so try to understand what's going on. This is more about designing agents. It's not really about creating something that works out of the box in 2 steps. It's more about the designing part. So try to understand the concepts of the code that we're writing. So yeah, this is another assignment. For some assignments, I have this bonus feature. So if you are done with assignment 4, you can come back here, more code. And then there is a final assignment, which I don't think we will ever reach this point. But once again, this website is for you. So afterwards, you can work on it. So we start working on these assignments. Whatever you can do here, I'm completely fine. And then it's up to you. You can continue with this today, tomorrow, next week, and then you can reach out if something goes wrong. But after the workshop, I will update also the solutions. So then it's up to you if you want to continue with the workshop. But that's the idea behind this website, because I see that you never know what happens during a workshop. All right, and that's pretty much it. How is going on with the API keys? Who doesn't have an API key? Who needs money for an API key? Because when I say who needs an API key, people are like, yeah, I need one, but I'm paying for it, so I can give you the money directly. I can give you 20 euros if you want. They're recording all this stuff. I'm really sorry about it. I'm sorry for those people who are gonna watch the workshop after, like what's going on there. Okay, shall we move? Do you also, did you manage to get the Serper Dev API key? Who doesn't have a Serper Dev API key? No? Why? It's not working? No? Ah, okay. You mean the Wi-Fi? Ah, okay. That's the problem I was talking about. Sometimes they have problems with the, because they know that I'm running a workshop and they get a lot of requests and they're like, okay, you're done, guys. No one is paying separate dev tool. Yeah. Yeah, I know. Okay, it's not a big problem, but with separate dev tool, please keep trying during the workshop. Keep trying with it and try to get an API key. Or if someone else has an API key, please share the API key with yeah, your teammates. All right. What about the setup guide? Do you have a working environment? Can you run some Hello World Python code? Who can't? I will walk around anyhow. So, who can't? Okay. Can we start with the first assignment? Yeah? I know it's a tough question, but who doesn't want to start with the first assignment now? Because if we start, we cannot stop. Not even for a coffee break. This is a tough workshop. All right, we start with the first assignment. Your first agent, essentially, here we want to build something very, very, very simple. And it's an agent that does prompt engineering and optimization. The background about this first assignment is that every time you write a query, I don't know if you know that, but every time you write a query in ChatGPT, OpenAI, what happens is there are a lot of things happening under the hood. So there is some sort of query enhancement. So the query that you create is not the final query that goes into the LLM, but there is an enhancement process that is getting your query and create a better prompt out of yours. And this is what we want to do here. So this first agent or crew, so a set of agents, what it does is getting a prompt, getting the LLM you want to send this prompt to. So let's say this prompt will be for ChatGPT 5, for OpenAI, for Claude. It gets this prompt and it does some prompt optimization, and it will fix your prompt. And then the output of this crew is a prompt, so it's a string, and this is the prompt that eventually you will send to an LLM. So we're not really sending this prompt. This is an application that takes your prompt, enhances your prompt, does some prompt engineering, and then it gives you the prompt as output. As you can see here, we have the input. We have the improved structure. It is whatever you want. So we get this input and we say, okay, improve the prompt. We optimize it. So then we want to have a second agent, if you want, a second agent that does the optimization part. So we get this prompt, we do the prompt engineering, whatever you want to call it. Then we have another agent that takes this input, this prompt as an input, and it says, okay, you want to optimize this for OpenAI. I'm going to do that. And then the final output is this optimized prompt. As we said, we need two agents, prompt structure agent, we can call it like this, and LLM optimization agent. And the inputs, of course, is the original prompt from you, and the output will be the optimized prompt. and also as input the target LLM. So I want to optimize this prompt for Claude, for Mistral, whatever. Okay. Here you have useful resources. If the links are broken because the documentation is changing very fast, please let me know. Otherwise, you just, I don't know, like go here, CrewAI docs, and you find whatever you need. Another good thing about the documentation, is the internet slow for you? We don't need internet anyhow. It's just for sending requests to the LLM, but it's really slow. Okay. And then you have the code examples. As I said, most of the times for each assignment, 80% of the solution is in the code examples. So you get this, you adapt it to your solution, and then you're ready to go. Okay, the first assignment, which is of course the easiest one, it's an easy one, but it's also the most difficult because it's the first time you're putting these things together. So give it a try. I'm walking around to help you, or you can come here, and it's just the first like stone that we're gonna put here, but then it will be easier. This is essentially the first time you're putting together the tasks, the agents, and the crew, but it will be easier afterwards. All right. So I give you some time, and then when we are all ready, we can look into the solution if you want. Okay. So if you have questions, just say it out loud, raise your hand, or you can come here. I'm turning off the microphone now, so we can also say bad things about CrewAI. First solution? No one? Okay, I thought I heard something. It's okay. I'm kidding, of course. It's not so easy. what I wanted to show you is that if you go to the documentation, you have some sort of agents running here under the hood, so you can actually talk to the documentation and say how to control output, and you get something. If internet is really slow, but that's the idea. So you can actually talk to the documentation without, like literally go into each topic. But the documentation is really useful. All right. I'm walking around if you need anything, okay? Because maybe you're still stuck at the first point, but you don't want to say it out loud, which is fine. Hey guys, I'm so happy that you're here helping me. So don't forget that you have the slides, right? So you have the slides in the website, in the description. So get those slides, and in the slides you will find essentially the code that you need for the solutions. Yeah. So here you need to put together the agent, the task, and then the crew. And for now, that's pretty much it. So once you put everything together, yeah. As I said, feel free to generate code. It's completely fine. But we are in the designing part, so it's better if you have a feeling of how to design this thing. Yeah, but of course, generation is completely fine as long as you understand what's going on. Yeah. Do I have to turn it off? Yeah, I guess so. I mean, it's fine. I'm not showing anything. It's okay? Okay. But in English. Do I sound like I'm Portuguese? I'm so glad. I'm so glad. I work a lot on my accent to sound Portuguese. I'll show you the website. One second, I'm turning this off. If you want to keep your laptop on and show your employer that you're working, you can use Caffeinate. Okay, since someone already finished the third assignment, no, it was a joke. All right, someone asked me something interesting, and essentially, one important thing about CrewAI is that is LLM agnostic, so you can use any LLM provider you want. So you don't have to use OpenAI. But that's also what I said before, that you can also use OpenRouter. If you want to know more about it, you can go here to the documentation and go to LLMs. And here you have a list of providers. If you use OpenAI, as I'm doing in this exercise, this is the default LLM, so you don't have to do anything on top of it. You just have to execute the code and it works. So you have it in your, you have the key in your environment and it works. If you're using something different, you need to explicitly say, hey, I'm using this LLM, and you have to pass this LLM to the agent or the crew. One example is, because someone is using it, I think it's Google Gemini. So you create your environment, and then in the code, you create something like this: LLM, model, Gemini, the model that you want to use, temperature is not important. And then you pass this LLM to the agent. If you go to agents, there is one parameter called LLM. This is also nice because if you want, you can have multiple agents using different LLMs. Maybe you know that one agent is about coding, and you know that Claude is really good for coding, and you can assign that LLM to that specific agent. So you can have different agents with different LLMs. In this case, some of you are not using OpenAI, so what you want to do is simply, when you create the LLM, let's see if I can find an example here. Okay. When you create the agent, you have something like this here, LLM, but what you're passing is a different one. It's not OpenAI. If you're using OpenAI, you don't need this in the agent. It just works. Don't forget to check the examples that we have here, right? So here you can find especially the inputs. Here I can show you how to deal with inputs if you want to use this way. Another way, of course, is that you wrap everything into a Python function or a Python class, but otherwise you can use this method. Who is done with the first assignment? Yeah, makes sense. Wants to move to the second assignment, or who wants to at least have a look at the solution of the first one? Okay, who wants to check the solution of the first one? How many? Who really wants to get 2 more minutes? Who is like, okay, I'm gonna conquer the world in a few seconds? Okay, that group. Okay, yeah. Funny fact, in the meantime, in the about, before, so I started like leaving, please rate my workshop section, and things were going really bad because whoever didn't manage to finish the assignments were always leaving a very, very low rating. So this was completely, and then I took it out. So I'm sorry, you cannot send the feedback. If you really want to send the feedback, you have to put your face. Just contact me on LinkedIn, and I will accept the feedback. If you say, okay, there were not enough jokes or things like this, I'm really glad. But no more ratings, anonymous ratings on the website. I'm sorry. And if you're interested, I'm also doing this My Data Guest. It's a series of learning stuff and podcasts with people from data. We have recorded an episode with Josh Starmer, who knows StatQuest. Yeah, he's a great guy. All right, we move to the solution of the first assignment finally. So what I'm doing here is not the only solution. Can you see the code? Is the font fine? Okay. So if you have done it differently, that's also fine. As I said, you can also you can be creative. So what we do here first is from CrewAI, we're importing the agent, the task, the crew, and the process. The first agent is the agent. So also this is also for showing you the designing process under the hood. So I'm thinking about, like, when I have to build agents. Now in this case we only have 2 agents in one single crew. When it comes with a lot of agents and I have a critical application running in production, I'm spending a lot of time designing the agents, because if something goes wrong and if I have to debug it, gets really complicated. What I have here is the first agent, which is about is a prompt structure expert. So it's about improving the structure, the clarity, completeness of input prompts. I'm leaving a backstory, and I usually use verbose because it gives me a very verbose output of what's going on under the hood, so I can see, okay, this agent is looking at this specific tool, this agent is accessing the web, and blah, blah, blah. All right, the second agent is the agent that, at least this is the way I designed it, is the agent that we're going to use for optimizing the query based on the LLM we wanna send the query to. So once again, the first agent takes our input, our string, which is a prompt, and then it sends this prompt to the second agent, and the second agent takes this prompt and says, okay, you want to optimize this prompt for Claude. I'm gonna do that, and that's it. Now, once we have 2 agents, the next step is to put them into a crew. In this case, I'm writing one single function just for convenience. You do it in your way. But for this specific case, I decided to create this function getCrew because I have some parameters and it's a better way to control the flow of the application. So here I have my first task, which is the structured task. This is the task we're going to assign to the agent, prompt structure agent. No matter what you put here, that's up to you. What's important is that, of course, I have to put the input data. I have to pass the input data to this task. In this case, the input data is the prompt, and is the prompt that I'm getting from this function. So I say, this is the task. This is exactly what the prompt structure agent is going to do, and I'm passing some input. This is classical Python, nothing special. Or you can do the input thing that I showed in the examples, which is also nice. Then we have the second task, which is for optimizing the prompt for the LLM. In the second task, what I'm passing is the target model, because the second task, we get the input. So the second task, which is the task for the LLM optimization agent, the second agent, we get the input from the first agent, so we already have that input. We don't have to take that input and pass it to the second agent. That's automatic. But of course, the second agent needs to know for which target model we're optimizing. And the way I decided to do it is that in the task, I'm saying optimize the enhanced prompt for target model, which is the variable that I get here. And then we put everything together into one crew, and in this crew we finally have the agents from structure and optimization agent, and then we have the tasks, the task for the structure, agent, and optimization agent. As a process, I'm using sequential. We don't have, this is the default process. I'm making this clear because you don't have to define the process here. It's always sequential unless you want to use hierarchical. And then I'm returning the crew. In the main function, I have the get crew, which is creating what we have seen a few seconds ago. And then once I execute get crew, I am passing the parameters. I'm passing the prompt. The prompt is write a story about a robot, and the target LLM is GPT-4. So it will optimize this for GPT-4. And then you call kickoff. This will execute the crew, and then I can print the results. Questions? I can run it, and hopefully this will work. Things, okay. Oh, come on. Things are changing very fast on my machine, I'm sorry. Let's have a look at the output. Oh, come on. So questions about the solution, is it what you did or? Sorry, I'm using poetry, but you can use UV. All right, I'm executing. Important things here. When you look at the output tells you everything about the things that are happening under the hood. Now it seems too much. It seems that you don't need it. When you have a big application, you don't know how to debug it, you will see that this is very important. All right. As you can see here, we are executing the first agent, and CrewAI is giving us information about what is happening. So CrewAI is saying, hey, I'm executing this first agent, and I'm doing exactly this. And you also see the thinking process under the hood. So you see what each agent is thinking. And then some other information. And then I have this prompt for ChatGPT-4 model, blah, blah, blah. And this is the final output that I'm printing as a raw string. But essentially, this is the full output that I get out of this agent. Now, who did it differently? Maybe we can add something to my solution. So do you want to add something before we move to the second assignment? You did something different, something it was not working. I saw that someone actually used CLI. Don't use CLI for this exercise because it's too much. It creates a structure that we don't need. Just work with pure Python. But essentially in CrewAI, you have this CLI option. And with CLI, it creates a structure of a project based on CrewAI standards. And this is useful if you are doing some extra stuff with CrewAI. If you're working with CrewAI Enterprise, we don't really care about this. We use pure Python for these assignments. And that's also what I usually do when I work with CrewAI. So the CLI functionality in CrewAI, yeah, it's something, they have their own CLI for cleaning the project, but it's not. Try to have a look into this because it's interesting, but we don't need it now. All right, can we move to the second assignment? Yeah. You mean in the crew? Yeah, you decide how the tasks are gonna be picked by the agents. Yeah, yeah. But this is the default. This is the default option. I put here for the sake of the exercise, but it's the default. By default, you get sequential. All right. If you don't have questions about this, we move to the second one. As you see now, that's why we have this website, because you don't have to rush. You know, it's not a race, but you can take everything with you afterwards. All right. Now we move to content creation with guardrails. Essentially here, what we want to do is create this agentic application that is creating content for, this is an example for a LinkedIn post, but we want to build some, let me double check one thing, yeah. But we want to build some guardrails around it. And this is what I said before, that if we have problems, this is something you can actually use in real life. Whenever you want to create an automatic solution for posting something on LinkedIn, on social media, the problem is that if you base that solution on the LLM, you don't know if the LLM goes, I don't know, how, yeah. So it hallucinates and it can create a lot of problems. So with CrewAI, let's say you have an agentic application, you have all these agents you're orchestrating, and you want to create something. With CrewAI, you can use this so-called flow. I'm leaving an example, but let's focus on the design for now. What we want to do is generate the initial content. So we generate the content that we want to post. Let's say our input is create a post about, I don't know, the hype around AI. And once we generate this content, we want to use some safety check. So we want to do some content moderation. We're going to use the flow. If we see that the output that we get out of this agent has something wrong, because there is violence or something is off, we recreate the output as many times as we want. And then when the output is ready and it passes our checks, we can publish it. Of course, we're not going to publish anything here. We're just going to get it as an output. But after the workshop, if you want to know more about this, I can show you how I implemented it with agents and NA10. Do you know NA10? Okay. Who works for NA10 here? 4. Okay. So what are we going to see new? Essentially, we have the things that we have seen before. In addition to this, we have flow. Flow, it's a big deal because when you look at it, it's a lot of stuff happening. but it's really simple. And once again, here you get 80% of the solution, even more. So with Flow, we have something like this. Essentially, we import the flow, and we have some decorators that are helping us to create the flow of the application. We start with a state, and I'll show you how is this used. Ask me questions about this, because at first it can be a bit intimidating, but it's not a big deal. So we have this travel advisor flow. What I'm doing here is creating a vacation plan, and if something is off, because maybe the budget is 200 euros and I'm going over the budget and I want to recreate the plan, I do it with the flow. So what happens here is that when I initiate the application, I generate the vacation plan, and when I generate the vacation plan, I'm calling my crew. This is a crew. We know how to create a crew. It's a crew that is creating a vacation plan. Once I have this result, I am saving this result into this state. It's called vacation plan. This state is defined here, vacation plan. And then, thanks to this decorators, I don't have to create if-then-else statements. I can just use a decorator that will help me with routing all the things that are happening inside the flow. With these decorators, I listen to generate vacation plan. It means that once this function is done, I automatically call the validate vacation plan. And I start the validation. The validation is another crew. It's a different one that only does the validation. I call this crew and I tell this crew, hey, I created some content before. I created a vacation plan. Take this and tell me if I'm over the budget. This crew has some agents, some tasks, and once this is the task where I'm passing the state of the vacation plan that I created before. I'm executing this crew, and this crew will return this flag, which in this case is valid. If it's valid, we can move to the next step. If it's not valid, we will take different actions. So what we do is plan valid is set to valid, or if valid is in the result. And once the execution of this function is finished, so we call the second crew and we ask the second crew, is this vacation plan valid? Yes, no. If the answer is no, what happens is that we will move to this next function, which is called right after the validate vacation plan. How can we know that it's called after this function? Because we have the decorator that says this function is called right after validate vacation plan, thanks to the decorator. If you don't know, the decorators are just changing the behavior of the function, but it's not a big deal here. The route vacation plan is all about checking the state. If it's valid, if is plan valid is equal to valid, it's true in this case, we return valid. Otherwise, we return not feasible or regenerate. Let's say that it's valid. If it's valid, we have this listener that is calling this function, and it says, hey, your vacation plan is valid. I can return it. This is the output, and we are done. If we return regenerate because the vacation plan is not valid, we move to this function. This is another router. So we move here, regenerate vacation plan, and we say, okay, I decided that we have only 2 attempts. So what I'm doing here is decreasing this generation attempts, and then I'm calling again generate vacation plan. Generate vacation plan is a function that we called at the beginning. It's for generating the plan. So we call again that crew. We say, hey, the plan was not good because it was too expensive. Generate another plan. And we do it again. We do what we have seen again. And once we do it, we reach either the state valid. If it's valid, we return the vacation plan. We can reach regenerate because the vacation plan is not valid, it's too expensive. Or if we don't have attempts left because we have to stop this loop after a number of attempts. Otherwise, it's an infinite loop. If we don't have attempts left, we move to not feasible, and we return plan is not feasible. I'm sorry, I cannot generate a plan. Okay, that's pretty much it. This is a super powerful concept in CrewAI. What are we adding on top of what we have seen in the first assignment? Only this. Only what you see here, which is the flow and a couple of things from Agentic. But it's essentially this. So now we want to have, again, one crew that is, even with only one agent, one crew that is creating the content, even one agent, one second crew that is doing the checks, is only in charge of checking if the content contains violence, for instance. And then we put everything inside the flow. And if you want to put everything inside the flow, you check what I did here, the exact code. You can also go on ChatGPT and say, hey, I have these two agents, adapt to my problem, if you want. Yeah, that's it. Let's, yeah, you can start. Now you are experts, so we're gonna spend 10 minutes on this. Come on. The best solution gets an autograph from Josh Starmer if you want. If you're wondering, I'm checking stuff from the conference because the people from the conference are always texting me. And then if you want to have only the fun part about this workshop, there will be the talk at 6:16 at 4 p.m. where I'm only doing the fun part without the boring coding that we're doing here at the workshop. So if you want to... Sorry? Yeah, it's pretty much the same talk, the same stuff, but I'm doing the talk. Yeah, it's a talk. Like building live, you mean? No, but I'm showing a demo. Yeah. But it's pretty much this, but only the talk. So where I'm showing this stuff, and then there is a use case that I'm showing, and I'm showing maybe a live demo depending on how much time we have. Yeah. Yeah. As I said, you have the website, so if that's the beauty of it. So you don't have to rush it. Of course, if you stay until the end, you will be a CrewAI master, but it's up to you. With the second assignment. Okay. That was easy, right? I mean, I gave you the code, come on. So, how much time do we have left? Who knows at what time we stop? At 1? 1 more hour? Wow. We're gonna have fun. So who needs a hint for the solution? Or who is, if you are stuck and you want to share it, yeah, let me know. Maybe we can share it and we can help the group. Who is stuck? Who is still in the designing phase? You're done, yeah. Have something to share? No? Who is going to join? I don't know if we can talk about it, but who is going to join the NDC Porto in 2 weeks? There will be another conference, I think here again. NDC. Last workshop I've done about agents, it was a 8 hours workshop. So this is easy. So I wanted to show you this thing about the Zepper Dev tool. If I have it here, hopefully. So if you import this and you have installed CrewAI, where is it? CrewAI tools like this, you should be able to import separate dev tool. But I also saw lately that if you install CrewAI, the latest version, you will also get the tools, so it should work. All right, who wants to see the assignment 2 solution? Yeah, the solution. Shall we move to the solution? All right. Okay. How is the workshop? Too difficult? Too easy? Easy? Difficult? All right. So essentially, as I said, the only addition that we have here is the flow. And we're doing pretty much is business as usual. And we're taking the things that we have done in the assignment 1. And in addition to this, to those things, we have the content creation flow. First of all, we have to define the state. This is what I'm using in the flow. In the state, I have the content that I'm creating, the flag that I'm using to check if the content is safe, and then the generation attempts. The content creation flow starts with the topic and the target platform. These are the 2 inputs that we pass to the crew. When we have the init, we're essentially asking for these 2 inputs. That's it. This stuff are done with Pydantic. I don't want to dive too much into this. It seems verbose, but if you know Pydantic, you know that this is really useful, because you're basically saying, hey, this class has 2 fields, and these fields have this description, they have to be string, and you cannot mess around this field. So it's really useful when you have stuff like this in production. So the first step is to generate the content. When I generate the content, I'm throwing everything in it so that you can see the actual crew. So when I generate the content, I start with 1 agent. I create a crew with 1 agent. And the content, this is the content creator. And the content creator is in charge of create a content about our topic. This is the input for the target platform and blah, blah, blah. I create this 1 agent crew and I kick it off and I save the state into state content. So the state goes here. And then automatically I go to this validate content, because this validate content is a function that is called when generate content is executed because of the listen decorator. Here I'm doing the validation. So I'm calling another crew. Here I'm creating a new crew with only 1 agent that does the validation. So it takes the output that I saved in the previous state and we grab that output like this, state content, and it creates a crew that checks if there is violence, inappropriate language, hate speech, and so far so on. This crew returns an output, which is, because I'm making sure that it works in this way, because expected output is a safety assessment of the content. So this, if I see that there is the word safe in the output, I am setting is safe equal to true. Is this safe in reality. It's not safe. You should use Pydantic. You want to have a Pydantic output that says output Boolean, and you can control it. If safe is true, we move to validate content. This is the third function, and this is the routing function. So here I'm routing to the approved, regenerate, or rejected function. So once I have the content, if it's safe, I decide what to do next. And I move to, if the content is safe, I return approved, and this listener, when I get approved, is calling this function, and everything works, and I have my content. If I have to regenerate because it contains violence, so is safe is equal to false, I am going to regenerate, and I'm calling again our generate content function, which is this one. And of course, I'm also decreasing the number of attempts. Now, what happens is, if I'm generating the content too many times, I'm running out of attempts, and then I have to move to rejected if I'm running out of attempts. And that's pretty much it. Then I have my main. In my main, I'm calling the content creation flow, our new flow, and you call it with kickoff, the same way you call the crew. And that's it. How was it? Too difficult? Questions about this? Comments? You want to challenge my solution? All right. So now we have kind of less than 1 hour. Let's say, yeah. But we can move to the fraud detection workflow. This is essentially this is a very weird workshop, because we start from something that you have never seen, and then we are adding up small things on top of it, but it gets easier because now you know how to create agents. So it's all about adding small things on top of it. And those who left didn't get the beauty of it, but it's okay. I'm just kidding. So what we do now is essentially we have the best way to explain what's going on in this assignment is by looking at the data that you have to use. These are the data that I'm providing. What happens is that we have this transaction list. This is just an exercise. It's not the best way to do anomaly detection, just for you to know. We have a transaction list, and we have some normal transactions and some anomalies. Imagine that this is a very long list, and you just have to identify which of these transactions are actually faulty transactions. Let's have a look at one anomaly. We see a withdrawal with almost 10K ATM Las Vegas at 3 a.m. With a very weird card number. The problem about this is that it's a high amount and the time is 3 a.m. Maybe it's fine because it's Las Vegas, but it can be an anomaly. And we have many stuff like this. So you can imagine that it's not really a deterministic approach. So we need maybe an agent that is looking at all this information. It's okay, maybe this look odd. Let's escalate to a human being. So you get this data, and one by one, or you decide how to do it. You give it to an agent. This is like, imagine that you give this to a prompt. You put it into a prompt and say, hey, tell me which are faulty. We want to do this with an agent. Essentially, we have the input transaction data that we have seen. We have detect anomalies. If we see that in one line, the number of anomalies is greater than 2, 1, that's a threshold that you have to set, we want to escalate. And then we want to create a final report. How I will do this? I will start with transaction analyzer agent. So it's going to analyze the incoming transactions and identifies the anomalies. I want to have a fraud specialist agent, which escalates with when we have a huge amount of anomalies. You decide the threshold. And then a normal, like a very boring report agent that out of whatever happened, it creates a final report. Poor him. Why is this assignment important? Because we're going to see how to use, first of all, conditional tasks, and if you want also hierarchical, but the most important thing is the conditional task. So we're going to have a task like this one that is going to be fired only when this specific function says that the anomalies are greater than 5, than 2. How does it work? We create a function, we define the output of this function with Pydantic, and then we give this function to the task, and we say, hey, output Pydantic is this one, and I missed something here. Let me fix it on the fly. Anyhow, this escalation is needed is basically a function that we pass to the conditional task, but we can fix it very easily here. It doesn't work. So the conditional task, as you can see here, this is a conditional task. So here what happens is that it's not wrong, but what I'm showing you is how to control the output. And I forgot to put the conditional task. This is for forcing the output of a task to be a Pydantic object. So the conditional task is really powerful because, as you can see here, we have a task which is assigned to this agent, data processor agent, whatever this agent is about. And the nice thing is that we're using is data missing. So is data missing is this function that we have here, which is doing something. This is a function that we use to call this specific task. If the condition is met, it means that we're going to call this conditional task. Otherwise, we don't. When in our context, in the context of the anomalies, we want to use we want to call this task when the function says, hey, here we have more than 2 anomalies. I think it's critical. What I want to do is to execute this task because it's a critical anomaly. Yeah. Yeah, that's a good point. In this case, we're working at a different level. We're not working at the level of the crew. When you work with the so this happens before reaching the end of the crew, before reaching the kickoff. When you work with the flow, you're reaching the kickoff, you're executing a crew, and you say, something is off. I need to go back. And if you think about it, it's also less deterministic. This is more deterministic, and it's happening inside the crew. So inside the crew, you are redirecting the flow, and you say, hey, don't go to that task, but go to this, because anomalies are greater than 5. Let's say that that agent has 2 tasks. One is only executed when something happens. So it's a different level. That's a good question. All right, questions about this conditional task? It's a task as the tasks that you have implemented until now, but you have a condition in it. Check this, the documentation of the conditional tasks. And yeah, maybe this is going to be the last assignment, but if we have time, we can also reach the last one, the AI-powered onboarding system, which is even easier. And this one, this is for you. Here I'm also implementing a Streamlit app. It's not really part of the workshop, but I put it here. Someone really wants to create something useful out of it. And if I have time, I will demo this during the talk today. Yeah, but the demo pretty much looks like this. So I have this interviewer thing. Who knows Streamlit? You know Streamlit? Okay, it's not a big deal. You can easily create an application with it. And it looks like this. Here I'm using asynchronous tasks and so far so on, so it's a mix of a lot of different concepts that you can learn. All right, this is one of the assignments that I like the most, honestly, because it's kind of useful. Okay, questions about this? Okay, who is tired apart from me? As I said, last workshop I did, I was in Bangalore, in India, and it was 8 hours workshop. I don't know why people signed up for that. I was like, what are you doing here? Come on. All right. All right, I was uploading the solutions from before, no, these ones. So now if you go to the website, you go here, and of course page not found. But I will fix this anyhow, it's in the repository, so you go here to About, GitHub, and this is the CrewAI workshops. And here now you find the solutions. This is also open source, so if you want to reuse the workshop template, it's for you. It's for free. Here you have the folder solutions, and you will find all the solutions. Now let's go back to number 3. So essentially with number 3 we have only one small thing in addition to what we have seen before. The first things we need for the solution is 3 agents. So we have the fraud analyst, the escalation specialist, and the agent that is about creating that is for the report. And we have a task. I'm wrapping the task in a function so I can have this parameter. The task for the transaction agent is given the transactions, so I'm passing all the transactions. Given the transactions, this is an important point. I'm not doing it one by one, just giving the whole file. Given the transactions, the fraud analyst is going to create something that shows the number of anomalies detected for each transactions. I'm using Pydantic because I want to be sure that I have an output that works for the next agent, so it has to be deterministic. Then I have the conditional task for the escalation agent. The escalation specialist will use this function, which is escalation needed? And this is the reason why we are returning the fraud detection task output, because then we're calling a function, and this function needs an input that it can read. And this function is really simple. We get the task output, which is the output of the previous task, and we look into the anomalies. So we take the output of the previous task, we go to output Pydantic anomalies. If anomalies is greater than 5, we take some actions. Which action? In this case, nothing special. Escalate flag transactions. We're not doing anything special. And then we have the task number 3, which is for generating the report. It's an easy task for an easy agent. And then in addition to this was my decision, I wanted to use hierarchical. So I am making this, I'm using a manager in order to create this hierarchical process. So I'm orchestrating the agents. And the manager is going to oversee the work of the agents and decide what to do next. This is really interesting because for the first time we're using process here. Where is it? Planning through. Okay, we're using a manager agent. This is a different thing. The manager agent is essentially, it's for process hierarchical, and I'm making sure that whenever we work on the tasks, so we're not taking the tasks in a sequential way, but we're saying, okay, you work on one task, and then you see that an anomaly a transaction has more than 5 anomalies. but maybe something else is wrong because I see that another agent is looking at those data and saying, hey, but I also see this. And then the manager is in charge of saying, I think we need to change the strategy. Let's do it in another way. In this specific problem, you don't see the huge benefit of it. But when you have an optimization problem where you have many different branches for your solutions and you have to go in many different directions and then go back and see, okay, maybe I have to reevaluate the output because I see that something has changed. Something has changed. I have to go back and rethink of my solution. That's super useful, and you're going to use hierarchical and a manager. I will show one example also today during my talk, because the main use case that I'm showing is based on dealing with an optimization problem. So yeah, once I have the agents and the tasks, I'm not doing anything different compared to the first assignment even. The only difference is that we have the conditional task. So one agent is not using a normal task, but is using a conditional task. And then the next step is to put together everything into a crew and kick it off. And that's pretty much it. Shall I run it? If you want. Let's see if it works. Okay, it's thinking. Let's see what happens. And here you can already see how important the log of CrewAI is, because now you have a conditional task and you want to be sure that is being executed whenever you have more than X anomalies. Okay, this is looking into our data. And it says final answer, anomalies, this, blah, blah, blah. Pretty much correct. Task completed. Okay. And then we have escalate flag and anomalies, because as you can see here, it says I'm executing these tasks, and I see that, let's see if we can find it. Escalation specialist, assigned to escalation specialist, and this is where we execute the conditional task if it's needed. And then we have the report generator that is creating a final report of the execution. Yeah, that's pretty much it. Who managed to implement this? Okay. I mean, this was just one additional conditional task. 10 anomalies? Okay, I found 7. Good for you. All right. That's also interesting, because he found 10, I found 7. I honestly never looked at this number, but this is the price to pay if you are working with LLMs and you have a lot of data. And if you're using LLMs, it means that you cannot really check it by hand, like it's part of the deal. All right, yeah, that's it. One more thing we can do before wrapping this up is showing you what this assignment is about. Essentially here, what we want to do, this is quite easy. I mean, we're literally doing the same stuff that we have seen in previous assignments. The addition is that we want to kick off the crew with asynchronously. So we want to kick off multiple crews. This is the onboarding system. So we have an onboarding crew that is onboarding new people joining a company, and it does several things. And you can actually think that this is a really smart way of using the crew, of using agents, because you have multiple steps. One is taking care of setting up, creating a report for setting up your laptop. One is creating your work email. Another agent is doing something else. First of all, you want to orchestrate that. If you want, you can say, let's use hierarchical because we want to see if everything goes well during the onboarding. Maybe another agent comes to us and say, hey, this guy is quitting after 2 days. The onboarding process stops, so you don't want to have sequential in that case. Another interesting thing is that we're using asynchronous. So if we are all onboarding, we can call the same crew multiple times against multiple people in parallel. And yeah, that's pretty much it. So you can have a look into this. You also have some extra stuff. And the code examples also in this case does most of the, it's 80% of the solution. And then the final one, which is, as I said, not really part of the workshop, but if you manage to do it, is this AI-powered solution with Streamlit, AI mock interviewer, sorry, which is an automatic interviewing system. Let's say you want to interview at Google. You can set these parameters here, and you say, okay, I want to interview at Google, software engineer, difficult, medium, and then it starts asking questions. And here I'm putting together all the concepts that we have seen in this workshop. So with this one, you can basically do everything, plus the Streamlit application. I can even talk to it with voice. I'm using OpenAI Whisper, which is, yeah, it's really famous now. So I can talk to this application and answer with my voice. And this is not really more than what we have seen during the workshop. So it's pretty much the same. So here we have questions that are created by the crew, and when one question is created, I have the other one which is being created under the hood as an asynchronous question, so I don't see this waiting time that you saw when I executed the app. So it looks really smooth. And then I write something here, yeah, while answering now, the asynchronous crew is creating the follow-up question. So is evaluating my answer. It will provide an answer now. It will provide some feedback. And then okay, and then as you see, it's giving me the feedback. And then as you can see, I already got the second answer, the follow-up answer. And this process will continue until you stop it. It looks fancy, but it's really easy to implement. And as I said, you pretty much know everything about the things that you need to implement this application. Cool. That's it. So we have kind of 5 minutes for questions or chatting about anything that is not data science now. Cool. Feel free to ask questions. Yeah. If you have. Or you can ask questions later. Good. Okay. So we can wrap it up and maybe go and chase some food. Cool. Thank you, guys. Thank you for staying until this, in the last minutes. Good.